So just to review from yesterday, the tangent is back on page, where was it? Back on page 489, and they kind of sketched it something like this. And I'm going to call that angle A. And I'm going to call this Q, R, and S. The tangent, what you learned yesterday, or last week, of angle A is equivalent to the opposite side over the adjacent side. Opposite side over adjacent side. Now these are sides, these are legs, not hypotenuses. Okay? Not hypotenuses. We will use the hypotenuse a little bit today as we learn a little bit more about ratios. Let's look at the sundial on page 494. It's kind of cool, actually. The structure shown is a sundial built on a sunken platform in Jaipur, India in the 18th century. The part of the structure above ground level is a right triangle. Its hypotenuse has the length of about 164 feet and makes an angle of 27 degrees with the horizontal. So what it means is, here's the horizontal, here's that hypotenuse. So this angle here is 27 degrees. About how far above ground level is the top of the triangle? In example 4, you guys will see how to use the sine ratio to answer this question. Sine on your calculator is like this. I know. Cosine on your calculator will be like that. So let's look at the two ratios that they have there on 494. I'll draw their triangle again. I'm going to call it angle Z, though, because I don't like the fact that they're using the same letters. So the sine of angle Z, they're calling it angle Z, is opposite over hypotenuse, which in this case would be side A over side C. Okay? Opposite over hypotenuse. Okay? Sine of an angle is opposite over hypotenuse. In the same way, cosine of angle Z is adjacent over hypotenuse, which in this case, the adjacent angle, what's adjacent, or the adjacent side, the side that's adjacent, is B. And the hypotenuse is still C. Okay? So again, by definition, the sine of an angle is adjacent over hypotenuse. This is a lot to remember, which is why you're going to have to memorize it, write it down, even if you write it in one little spot. And you're going to find when we're done with this lesson, there's an awesome summary on page 496 that if I were you, I would copy it, and I would maybe write it on a note card, something, because it's very handy to have. Okay. Let's take a look at example 1. And again, you're just following the little schedule that they gave us. For sine of an angle, it's opposite over hypotenuse. Or that should be cosine, Mrs. Myers. For cosine of an angle, it should be adjacent over hypotenuse. For triangle JKL, find the sine and the cosine of L. So the sine of L and the cosine of L. Let's look at the sine of L for a minute. L is in the bottom right. It's right over here. And the rule for sine is opposite over hypotenuse. So opposite is 8. Hypotenuse is 17. Okay? That's all they're asking. How about the cosine? Well, the cosine is adjacent leg over hypotenuse. Well, we've got a hypotenuse and we've got an adjacent leg. So adjacent leg is the numerator. Hypotenuse is the denominator. Okay? So following what they ask for will help you answer these questions rather easily. Okay, let's go into the land of calculators. Since I got people swiping my calculators. Example 2, the sine of 38 degrees. The sine of 38 degrees. Now on Haley's calculator, what you do is you do 38 and then press sine and it does that. Check your calculator. See if you know how to get there. Same job for B. We're in example 2. Did everybody test their calculator? Example A? All right, example B, cosine of 43 degrees. So 43 cosine. This is Haley's calculator. Yours might do it slightly different. And you should have come up with that. Okay? Every calculator has a little bit of a different way of doing it. Is there anybody whose calculator didn't give you the correct answer?
I can't check because mine needs a constant solar source.
Your what?
I can't check because mine needs a constant solar source.
Oh, so the lights aren't working good enough for it. Okay. There we go. Let's do checkpoint 1. Everybody, if you have a calculator, give me the sine for 74 degrees. Are you okay with this? Okay, so sine for 74 degrees. 74 sine. Did you guys come up with that? It also wants the cosine. Oh, and it says 4 decimals. So this would be 0.9613. Look at the 6. It tells the 2 to increase by 1. Checkpoint 1 also asks for the cosine of 12 degrees. 12 cosine. 9781. 0.9781 would be the rounded version. Okay? Now, to use this information, I'm ahead to example 3. They've got a triangle drawn. Here's angle D. I've got a side. I've got a hypotenuse. And I also know the measurement of angle D. Okay, so I know a side and the hypotenuse. When you know one of the sides and the hypotenuse, you can either use sine or cosine, depending upon what you have. We happen to have the adjacent side. Which ratio works when you have adjacent? Cosine, good. So in order to ascertain the value of x, we need to use cosine of 41 degrees, which will give us adjacent over hypotenuse. What's the cosine of 41 degrees once you shove it in your calculator?
175.
We'll go 4 digits. 7547 equals x over 16. Okay, so you have to solve what the cosine is with your calculator. And the cosine of 41 degrees is 7547 10,000ths. To get x on its own, multiply both sides by 16, and you should end up with 12.1 blah 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 blah. Okay, so your answer is 12 1/10 would be a good measurement for x. Are you guys okay with this so far? It really takes a lot of thinking. Did I know the opposite side? If I knew the opposite side, you use sine. Did I know the adjacent side? If I knew the adjacent side, use cosine. And if I did not know the hypotenuse, but I knew the two legs, that's when you use tangent. Yes? So, let's go back to our height of our building on page 494. To find the height shown, we're going to re-sketch this little guy. I know that this angle here was 27 degrees. How do I know that? Because the story problem said so. Its hypotenuse makes a length of about 164 feet and makes an angle of 27 degrees with the horizontal. So this here is the ground, aka horizontal line. Okay? So I know the hypotenuse, I know an angle, but what do I do to figure this out? Well, I am looking for the side opposite the angle, right? Which one uses opposite, sine or cosine? Sine. So if I use whatever the sine is of 27 degrees and opposite over hypotenuse, I will be able to find the value for the opposite side. What's the sine for 27 degrees, folks?
4.4534.
Okay, good. She rounded it, and it became 4.454. Multiply both sides by 164, and you will find that the height right here of what we're searching for is 74.456, and they tell us how far is it to the top. Since they said about how far, I would answer it with a whole number. Okay? Since they said about how far, I would answer it with a whole number. If they said round it to the nearest foot, I would answer it with a whole number. If they said round it to the nearest tenth, I would have said 74.5. Okay? Because the 5 tells the 4 to go up 1. Does that make sense? Are you guys okay over here?
Yes.
Turn the page for me. Oh look, a summary. This is one of my favorite summaries in the whole book. If there was one summary I would copy into my spiral with flashing lights and highlighters, it would be this one. I would guarantee you that when you do the next couple of sections, the review, the test, this summary is extremely helpful. By the way, at test time, you will have access to this. I'm not going to expect you to have it memorized because I'm 43 years old and I still, every single time, have to look up what the cosine is, what the sine is, what the tangent is, okay? So maybe I'll have it memorized when I die, but I'm not there yet, okay? I do know the Pythagorean theorem, though.